Okay, my Mattel Aquarius on a television is a little bit rough. It's not locking the phase very well, and it also drifts out of tune as well. You can hear a beeping going on. That's just a little test program that I've got running, and hopefully that'll make sense in a few minutes. So basically, I've been having a look at the RF modulator and seeing that there's a way I can bypass it and just get the video signal straight out. The first thing I will show you is the video. So this is the video input to the RF modulator here, and as you can see, there we are. We've got the video signal, but it's not particularly powerful. It's only about half a volt peak to peak. But what's more concerning is the DC offset. So if I click on there, you can see that the DC offset, that's half a volt per division. So the DC offset is 2 volts. So there's a 2 volt DC offset there. Okay, so that's not particularly good. If I now change this to 2 volts division and bring this down a bit, I'm now going to show you the audio signal. And the audio signal is very strange as well, in that there you go, you can see it beeping away, but that's got a 12 volt offset on it as well. Right, now the 12 volt offset on the audio is not so much of an issue because I can put that through a capacitor and get rid of it. But when I come back to the video, it's weak and I need to get rid of the DC offset. However, when I've just looked at the circuit board, apparently somewhere in here there's a bit of a voltage divider going on. The output from the video chip should indeed be higher, and it is. So if I now go onto the video output pin, get this right, there we go. So if I go actually onto the pin, and this is now set to 2 volts per division, you can see that I'm getting a good 2 volts, if not more, signal coming out of that video chip. So there's a nice, strong, healthy signal. But again, I've got this problem in that there's a horrible DC offset of that's going to be 6 volts. Okay, a few days have passed and I've actually done a few little modifications, but I've got it working absolutely fantastically well on my CRT television. I mean, that is as sharp as I think you're ever likely to get. Don't worry about the lines that are flickering up the screen, that's just because of this camera. You can't actually see that in the real world. There we go. I mean, that picture for me is everything I could possibly have hoped for out of the Aquarius, out of this 40-odd-year-old technically analog on the video side technology. Okay, so what changes did I end up making? Right. Okay, so here's my experiment. I've obviously done something. Okay, so this is where I got to. There is in the Aquarius a TEA 1002 chip which provides the video output which goes to the RF modulator. Now the RF modulator has been removed. That's out of the circuit. Now on this output, I'm getting a 2 volt DC offset and a 0.5 volt peak to peak, which is really too low to feed into my TV. I'm really looking for a 1 volt peak to peak and a 0 volt offset. Coming out of the chip, I've got about 2.5 volts peak to peak and a 6 volt offset. So I should be able to voltage divide this 2.5 down to get 1 volt peak to peak, which is great, but I really need to get rid of this DC offset. Just so happens that there's a DC offset input pin, pin 9, which at the moment is held to 12 volts via a 10k resistor. When you look in the data sheet regarding this pin 9, it does different things depending on what voltage you apply, and it wasn't terribly clear what exactly the different numbers were trying to achieve. But that's where I was. So I've altered the circuit to this. So pin 9 is now fed through a potentiometer, so I can change the voltage between 12 and 0 volts. Now it just so happens that inside this chip, according to the datasheet, there's a 1K resistor. So I'm assuming that removing the 10K and having it set up like this is fine. Okay, that is a big assumption, but it says it's DC input, so this is my DC input. Okay, in terms of the output, what I've figured out in order to get roughly the 1 volt is that if you feed the output through a straight 500 ohm resistor to the TV, with the earth then returning to ground like that, and because this is obviously a 75 ohm impedance signal, impedance cable, then I appear to be getting roughly the right sort of voltage that I need for my video signal. And although I can't cancel out all of the DC offset, I appear to be cancelling out enough to make the television picture work, and that is what I'm getting. But obviously I'm very concerned that if something nasty was to happen here and I was to get a spike back through this, what damage I might do to the TAA. You know, and obviously I've still got this question mark about whether this input is correct. But that's what I'm doing. That's working for me at the moment. But am I frying the chip? Have I made a big mistake? I don't know. Okay, so that little mod's got me to an interesting place. If I go onto the video output, we can see that we've now got our 1 volt peak to peak video signal, which is perfect. Really happy with that. I'm not so happy about the fact that we've got a 1 volt DC offset, but that's the price I think I'm going to have to pay. The TV obviously doesn't have an issue with it. Well, it appears to be working great, and the sound's working, so that's good. Obviously this is just with my television I've got here. Maybe other TVs won't be as forgiving of having the 1 volt DC level on the output or the input to the TVs. I'll have to cross that bridge when I get to it. Now, I'm not recommending anybody copies this, but what I am showing you is what I have done and the results that I've got out of it. Just how long the Aquarius, or indeed the TEA 1002 chip, will last in this configuration is anybody's guess.